Hey everybody, this is your week 27 second grade science lesson. Now, first thing I want to tell you is I have loved getting all of your pictures of your sun hats. You guys have been really creative at using all of the materials that you had provided and really doing the testing and research to figure out which part of the hat should be made with which material. I saw a lot of sweat soakers with paper towels and even the paper bag. Some of you were really creative in the way that you used your tinfoil. Some of you used it where it would reflect the sun off the top of your head, kind of give you some reflection. You made sure that you used the paper plate or the paper bag out to give yourself a really good brim to cover your face, and making sure that you had extra material in the back to cover your neck. So you guys were really good scientists and really good inventors to make sure that you had all of the things that you needed, or you used what you had to make sure you could still have a hat that would cover your head. So I'm super proud of you. So if any of you haven't had a chance to send me any of those pictures yet, there's still time. Send it to me. Probably next week, I've been keeping track and keeping pictures of all of the cool insects that you created and drew for me. The really, really cool fish. A lot of you have sent me pictures of the fish that you either drew or created. And then now with these fun sun hats, I'm gonna have just some slides so you guys can see what some of your other friends in the different Da Vinci classes have been doing since we didn't get to have these lessons all together. So I'm really proud of you. You've done an excellent job. One other thing that I need to tell you real quick is I'm going to give you a lot of instruction right now, and then you guys are going to be on your own to watch our mystery science for this week. We've been having a lot of technical difficulties with trying to get the videos synced up. That means so that I can talk and we can go through the video together, just like we were in class. For some reason right now, we just can't make it work. It probably has a lot to do with how many people are using the internet. And I don't know, it's also been a really stormy day here. Something weird is happening upstairs at my house. So what I'm gonna do, so moms and dads, if you're listening too, I'm gonna give you some instructions, and then you guys are gonna watch the mystery science on your own. And you're gonna do the experiment at the end. So one of the things that I want to talk to you just a really quick minute about is, have you ever thought about, what candy and plastic have in common? Have you ever thought about that before? Maybe not. One thing that this experiment is going to show you is what toys made out of plastic and chocolate have in common, or how you can use the properties of chocolate to kind of help you figure out why toys are made out of plastic. So that's what the video is about. And the experiment is going to be doing an experiment on melting. So this is going to be one where you're going to need parents' help and permission. So all of the supplies that you need are going to be listed on the supply sheet that you get with this lesson video. I will make just a little more detailed explanation on the sheet, but you guys will be able to go through the video and pause it whenever you want to and do your experiment and use your worksheet to write down your findings. So you're going to need at least 2 different kinds of candy. Now on the sheet, I've listed that you can have up to 3. You can actually melt as many as you want. For this experiment's purpose, you would have been working with a partner and you each would have had 1 candy that you would have been in charge of melting. So if you want to melt 2 candies, 3 candies, 4 candies, great. But you're going to want different kinds of candies that have different properties, and you're going to see which kind of candy melts faster, more slowly. So you're going to want to use things like chocolate, or you could use like a gummy candy, like a gummy bear or a Swedish fish or a gummy worm. You could use, it says, kind of a middle melting candy, and that could be like a Starburst or a caramel or something like that. It's Easter time. You may have things like jelly beans or Peeps. That's my dog. But you are going to want to have a couple of different types of candies that you can experiment with melting. So this is a really fun one. And one of the best things about melting candy is after you melt it, it still tastes good. So you can enjoy that. Now you're not going to want to melt a whole bag. You're only going to melt a few pieces of each kind. So you're going to need candy. You're going to need some Ziploc bags or some zipper plastic bags. You're going to need a container that you can melt. How many of you have ever melted water? Can you melt water? You're going to heat up water. You need hot water. So you're going to have something that you can heat some water up, a little plastic container. You could use a little saucepan. You could use a glass bowl, whatever you need to be able to heat some water up. So you need parent permission and some supervision to make sure that you get the water hot the right way and a safe way, whether that's straight out of the tap, whether that's in the microwave, or even on the stovetop. Some of us have faucets and the water comes out really, really hot, and that will work too. So you're going to need a container to put your hot water in. You're going to need something that can hold the plastic bags down while you're doing the experiment. So in the instructions I put, you can use a spoon, you can use a straw, you can use a popsicle stick, you could use a knife, you can use anything that you can, because you need to make sure that those Ziploc bags are pushed underneath the level of water so that they'll melt for the right amount of time. I think that's all of the supplies. Hopefully that makes sense. So with this video, the video will play after me, but it won't be me with you. So you'll just be able to watch that and go ahead and pause it whenever you need to fill out the worksheet, and also to answer the questions as Doug asks you. He's going to ask you questions about what you think about this and that. So go through all the video, and then at the very end, you will have on the paper, on the Google Sheet, you'll also have 3 extra videos that you can watch that have some things that are melted, and you guys can watch those videos about different things being made, glass melting and things like that. So this is going to be an assignment for you to do this project kind of on your own, but I still want to hear about how it went. Let me know, what was your favorite candy that you melted? What did it, how fast did it melt? How did it taste after it melted? Don't eat it while it's hot. So this is going to be a fun one. I'm really sorry that we can't go through it together. Hopefully we'll be able to figure something out for next week's Mystery Science, but it's no fun to watch the video with me and have it jumping and skipping and lagging. It's no fun. Not much fun for me and no fun for you. So have a good time with this one and let me know how it goes.
Hey, this is Doug. I want to show you something. I don't know if you've ever noticed this before, but toy cars, action figures, dolls, Legos. Have you ever noticed what material they're made of? So many toys today are made of plastic. Why is that? Why are so many toys made out of plastic? Well, it turns out we haven't always made toys out of plastic because plastic had to be invented. Before the invention of plastic, now I'm talking about the time of your great-great-grandparents, their toys were made out of a different material, wood. Some of these toys were actually very nice, but there was a problem. These wooden toys took a long time to make because each toy had to be carved by hand, like this. Wooden toys were expensive because it was so much work to carve even a single toy. Even a little wooden toy like this might cost an entire week's pay. So that would be like this little toy hippo costing a few $100s. Isn't that crazy? So many parents had to make toys themselves by carving them from wood in whatever little free time they had. So most kids were lucky to have just 1 or 2 toys. You can understand why people started to ask themselves, wouldn't it be great if there were an easier way to make things? Like, imagine if all you had to do was carve 1 toy, and then you could just hit a button to make copies, and poof, you'd have lots of the same toy in almost no time. Now the toys would cost less to make. Every child could have more toys. What you'd really need in a situation like this is a faster, easier way to make a certain shape so that you could make lots of toys all at once. Like, what if you want to make lots of copies of this lion shape? Can you think of any way to do that? I'll give you a hint by showing you an example totally different from toys. Say if instead of toys, you wanted to make a bunch of popsicles. Like these awesome lion-shaped popsicles that are sold at the zoo. Now, what could you do to make lots of these? You know you could take a big chunk of ice and you could carve it into an animal shape, but that would take a long time, and you don't want just one. You want a whole bunch of these the exact same shape. Can you think of an easier way to do it? How do you think popsicle companies make lots of copies without having to carve each one? I gave popsicles as an example because notice there's something special about ice. Ice is a material which has this property where it can melt into a liquid. Like this, watch. This is an ice cube quickly melting on a hot frying pan. You see it's becoming a liquid? It's water. Water is just the liquid form of ice. Ice is the solid form of water. Ice has the property of being meltable. Being meltable is a really useful property for a material to have because you can pour a liquid into any shape you want. Like if I pour water into this ice cube tray with rectangular shapes, and then I freeze it back into a solid, out comes a lot of rectangle-shaped ice cubes. Or if you had a tray with shapes like this instead, you'd get monster-shaped ice cubes. Liquids always take the shape of the container you pour it in. So if you want a bunch of lion-shaped popsicles, all you need is a lion-shaped tray. You can keep making lots of special shapes with ice over and over again for very little time or work. But what does this have to do with toys? Well, obviously it wouldn't be a good idea to make toys out of ice. They'd melt in your hand. And wood as a material, well, wood doesn't have the property of being meltable. There's no such thing as liquid wood. Remember, most toys today are made out of plastic. You see where I'm going with this? Plastic. Why do you think toy companies started using plastic to make toys instead of wood? What do you think might be so special about plastic? It was in the year 1856. A scientist named Alexander Parkes was experimenting in his laboratory by mixing different chemicals. When he mixed cotton with strong acid and other chemicals, he accidentally discovered a new material: plastic. One of the things that was so great about this new material was that just like ice, plastic has the property of being meltable. Like, look what happens when we heat up these plastic army men over a stove. Whoa, you see this? Plastic melts into a liquid when you heat it up. And unlike ice, which melts even when it's just a little warm, plastic melts at a much higher temperature than ice. So plastic won't melt in your hand. Once you get plastic really hot and it melts into a liquid, you can then squirt it into any shape you want. You can squirt it into a dot shape, like you see here, or you could squirt it into a Lego man shape, or toy dinosaur shapes, or any shape. So when plastic was invented, for the first time in history, it was possible to make millions of toys, since you could pour liquid plastic into a shape and just let it cool. That made it easier and cheaper. If your great-great-grandparents could walk around a toy store today, they'd be amazed at how many toys there are and how much cheaper they are thanks to the invention of plastic. I should point out to you that ice and plastic are not the only materials that have the property of being meltable. Metal and glass are two examples of materials that can be melted too, and they can be poured into shapes. If you want to see some really amazing videos of metal and glass in their liquid form, check out the videos in the extras. Right now, though, look around you. Can you think of any materials that melt? In today's activity, you're going to experiment to find out what kind of candy melts, and more importantly, what kind of candy doesn't melt. You're doing this experiment to help a friend who has a big problem. You see, you just got a postcard in the mail from your friend. They've been gone all summer visiting a summer camp called Camp Way Too Hot, which is located in the American state of Florida. Let's read what your friend wrote, shall we? Camp is going okay, I guess, but it's 10 miles from the nearest store. We ran out of candy on day 2, and we have 2 more weeks to go. Please send candy. Now, the only way for mail to get to Camp Way Too Hot is by truck. And that truck has to drive for miles in the Florida sun with no air conditioning. It gets really hot inside. You want to send your friend candy, but you don't want it to melt in the truck and arrive as a box of melted goo. That would be a disaster. If you've ever left a chocolate bar in the sun, you know that it has the property of being meltable. Just like plastic, chocolate can turn into a gooey liquid. It loses its shape completely. But is all candy meltable? Today, your class is going to heat different candies to see if you can find one that won't melt. You'll see whether the candies stay solid, melt into a liquid, or just melt part way, getting soft and squishy. Then your class can decide what kind of candy you would send to Camp Way Too Hot. You ready to begin? I'll talk you through the steps one by one. To the top of your worksheet now. Your teacher can tell you what kind of candy you have. Your teacher will pass out hot water. Put it on the plate, but don't open the lid yet. Open your container and put in the bags of candy. Use your sticks to push the bags underwater for 2 minutes. Discuss these questions while you wait. I'll put a timer on screen so you know when 2 minutes are up. You ready? Here we go. Look at the candy while it's still in the hot water. Did it lose its shape? Circle your answer on the worksheet. Out the bags and squish the candy with your fingers. Then finish your worksheet.